Alright, so for what it's worth, I'm just driving out from house to our consultation with a prospective client. Is he a client? Is he become a client when they buy the solar system, or are they a client when I turn up on their doorstep to have a conversation about selling them one? I don't know. Anyway, so I want to talk about aviation contrails. Those of you who know me will know that it's one of... Okay, sorry about that. Back to the video about aviation contrails. My constant companions. You can see two of them just up there. Now the reason they come to mind is, well, they're always in my mind because I've got an aviation contrail fetish. But I was having a chat with this guy today about the solar power system that we're discussing. He was telling me that he's already got a solar power system on another property, and when it went in there was a few technical difficulties with it, so he got really involved in figuring out how it all worked. And he was telling me that this 10 kilowatt system never ever put out 10 kilowatts, which is fair call really, because the 10 kilowatt rating is the rating of the modules, and you'll have losses in the cables and losses in the inverters and so forth, so it's not necessarily that surprising. But what I was saying to him was, you know, the amount of energy is also influenced by, and I waved my hands in the air at the high level cirrus clouds, which are like this very faint wispy clouds, as opposed to like the cumulus, which are the big sort of fat clumpy ones. And I said, you know, because of the albedo effect, you'll get some reflectivity of the sunlight on from those clouds, and I was basically talking about global dimming, and that will reduce the amount of solar energy falling on your solar panels. Probably not by much, by a few percent maybe, I don't know. It's an interesting question. But then I got to thinking, as I'm driving away from that property and I see these really distinctive aviation contrails, which I'll show you again, just up there, you can see them. And as I was looking at those aviation contrails and just sort of trying not to get distracted from driving the car at 110 kilometers an hour, you could actually see the shadow cast by the aviation contrail. And at one point I think it was casting a shadow on the other contrail. And so it's fascinating. If you had the right, because when I took my glasses off you couldn't see it, so I must have like a Polaroid lens that allowed me to actually see that or something. But there's also an interesting thing called a distrail, which is a aviation contrail. So if you have an aeroplane that flies through clear air, it can leave a contrail. But sometimes if the plane flies into a cloud, the heat and the exhaust and the water vapor in the exhaust will actually basically leave a hole in the cloud where there is no water vapor droplets crystallized, and that's called a distrail. And so there's some really interesting chemistry. Anyway, so what causes an aviation contrail? So if you look at the fuel that goes into an aeroplane, which is aeroplane fuel, is basically kerosene, right? Jet fuel they use in airliners is basically kerosene. And a kerosene molecule, if you can describe such a thing as that, is basically, or can be crudely described as a long chain of carbon atoms. Busy, that's another phone call, sorry about that. So, kerosene. A chain of carbon atoms, 17 carbon atoms long, surrounded by a ring of hydrogen atoms. And when you squirt that into a jet engine and ignite it in the presence of large amounts of oxygen, the carbon and the hydrogen dissociate and release energy, which heats up the gases that are formed in the engine. And the carbon grabs hold of the oxygen from the air to make carbon dioxide, and the hydrogen grabs hold of the oxygen from the air to make water. And so what gets squeezed out of the back of the jet engine is basically a gaseous mixture of carbon dioxide and water. And where the planes fly, which is in the lower stratosphere, it's about -50 up there. So you get the hot gas come out of the exhaust pipe. I think it is around about 600 degrees Celsius. And the hot gas with that rich in water vapor crystallizes, the water vapor crystallizes in the cold air. Now, it doesn't always crystallize in the cold air because it needs a nucleating agent. But sometimes the nucleating agent is the soot particles that come from unburnt jet fuel. So there's a bunch of complexities in there. So which is why sometimes you'll see a plane flying that will be leaving a contrail, and other times a plane might be flying that's not leaving a contrail. There might be at different altitudes, there might be different amounts of water vapor already in the air, there might be different temperatures, there might be different amounts of nucleating agents in the exhaust plume. So there's a whole bunch of stuff. Now, but what happens is this: when you actually get a contrail form, it's basically a whole bunch of ice crystals, and ice crystals are white. And so what happens is you get that hard white streak, which is basically a long artificial cloud. Well, I mean, it's a cloud, it's just made by humans. It's an anthropogenic cloud, a linear anthropogenic cloud. You can see we're creating a little idea here, a meme, a linear anthropogenic cloud. And then what basically happens is that thick, hard cloud dissipates over time. Sometimes it just sort of boils off and disappears. Other times the ice crystals persist and then they spread out. And then eventually, if they spread out enough, what you can have is that the entire sky is actually blanketed by the remnants of these contrails left behind as, I think, what you would call high altitude cirrus clouds, which basically makes a nice bright blue sky turn into a pale blue sky. And what that means is that there is a proportion of the sunlight falling down to the ground which is no longer getting to the ground because it's been reflected off these ice crystals. And that's called global dimming. And if you know your global dimming story about the atmospheric scientists who were driving to work on the days after September 11, when aviation was shut down over the United States for 3 days, they drove to work going, boy, isn't the sky blue? Because these atmospheric chemists or physicists or scientists had probably never seen the sky without aviation contrails, because the first aviation contrails went up in about the 1940s. I think this is back in the Second World War, where they really started to ramp up long-range bombers and high-altitude flights, is where they would have first come across aviation contrails, because you've got to get up into the relatively dry, very cold air in order to form them, which means you've got to get up into the stratosphere. So if you can tell me what the first plane was that flew in the stratosphere, then that would give you an indication of probably when the first aviation contrails formed. Anyway, so the point is about the global dimming is that it reduces the amount of sunlight reaching the Earth, and that changes this thing called pan-evaporation rate, which is basically the rate at which water evaporates from the surface. And when these guys started doing the studies into global dimming as a result of the September 11 shutdowns and this newfound interest in how the physics in the atmosphere worked, they discovered this phenomenon called global dimming. And global dimming is actually problematical in a way, because what global dimming does is it actually cools the planet. So that's a good thing that it cools the planet, you could say. But if your global dimming goes away in a hurry, for example, because you ground the global airline fleet, then you could potentially have an uptick in heat because the cooling element has gone away. And this is one of the concerns about the aerosol masking effect, which is kind of the same thing. Aerosols also reflect sunlight and have that dimming effect. Aerosols being tiny physical particles like specks of dust and sulfur that comes out of power stations. And one of the big concerns is if we turn off all the fossil fuel generators, that we will reduce all of these aerosols going in the atmosphere, which are helping to shade and cool the planet. So whilst you'll get a long-term CO2 impact of reducing temperatures over time, you'll get a short-term heating. And one of the concerns is that short-term heating could bounce the planet temperatures up way above the 2 degrees. And so there's a lot of conversation about that. But let's just go back to the aviation contrails for a moment. Because if my thesis is correct that these aviation contrails leaving the high-level cirrus clouds can reduce the amount of sunshine falling on the solar panels, that means that those airliners are costing my clients money, because they make their money from having photons of visible wavelength light falling on their solar panels, which then converts it into electricity, which then subverts their power bills. So these aviation contrails, these airliners, are contributing to my clients losing money. And I just want to protest that on behalf of my clients. And I think that we should levy a small fee for air travellers called the Solar Power Efficiency Reduction Fee, the FRCFC fee, or whatever the acronym would be, in order just to kind of try and make that right. So everyone that flies in a plane, I want you to send me some money for your contribution to the high-level cirrus clouds, and I'll forward that on to my solar power clients. Promise. Okay, for what it's worth.